Hello everyone, thanks Duong for presenting the first part of this tutorial. As Duong mentioned, I will go over and focus in my part of this tutorial on virtual environments. So why we need these virtual environments for traffic scenarios. So this is just kind of motivation why virtual environments are important for traffic scenarios, even for autonomous driving software. First is we can simulate complex traffic scenarios in a controlled and repeatable way. Of course, saving time, reducing costs, increasing safety in testing is also one of the important aspects or advantages of virtual environments. And it also enables a large-scale testing, which is otherwise impracticable or unsafe to do in the real world. I will show later on some scenarios and what we achieved so far. But these are the big advantages of using virtual environment. Of course, there is another one which can be used, or the virtual environment to enable the training of AI algorithms, because you can generate a vast amounts of training data, ideally photorealistic images and visuals. So what are the challenges of testing in real-world traffic scenarios? So first of all, it's time consuming. As I mentioned before, it's like take a lot of time to have a scenario, real-world scenario test with multiple vehicles, actors, and so on. It's expensive because you need to do all the investments in the infrastructure, vehicles, and personnel. Regulations, you cannot test all these scenarios in every location, let's say, in the world. So there are different regulations, different countries. Weather conditions is also important. In some situations, you are going to test, for example, in rain conditions or snowing conditions and so on. So you need to wait under this weather conditions like are fulfilled in order to do your tests. And of course, there are some risky scenarios where, like, you are focusing, for example, to have a crash or dangerous scenarios with pedestrian appearance, for example, child on the road and so on. It's difficult to do in the real world. And this is why virtual environments helps in this kind of testing and simulations. So first of all, you can do control testing. You can define more or less your test scenario, or you can script it. It's cost effective because you don't need all the infrastructure and the physical setup. It's scalable because you can simulate thousands of scenarios simultaneously, which also accelerates the development. You have also consistent environment where you can repeat the test again and again. For example, if you have one specific scenario and when you do the test and it fails because maybe your software is not prepared for this scenario, so you can make sure after you improve your software system that the same scenario which failed before is now succeed. Of course, with the weather flexibility, you can add all the different weather conditions, snowing, rain, and so on, just with a click of a button. And last but not least, all the ethics challenges can be, for example, done in a virtual environment without any risk. So what are the use cases? As I mentioned before, stress testing of autonomous driving software, the training AI algorithms of this software, unit testing and continuous integration, continuous delivery pipeline. So this means when every time you do changes in your software, you can automatically trigger this unit tests and make sure that the changes in your software does not break anything in the system. And of course, scalability of simulations is one of the use cases. So I'm just showing here a video. I hope you can see the video. It's a very simple video, but just to show you the use case here, what we are doing. What you see here on the bottom left side is a software called OpenPilot. So OpenPilot uses kind of ADAS system. We didn't manipulate this software. We took this software as it is, but we connected it to the cameras of a virtual environment. The virtual environment here on the top right side, which is implemented as a very simple Unity application. You can see The environment is quite simple. You have only the roads, you have some like buildings and so on. But it shows that you can easily connect this virtual environments to existing systems. You can add more cars, more traffic scenarios in your simulation. This is, for example, a scenario with a lot of cars. So you can see here the perspective, which is like captured from the software OpenPilot, but this is what you here define in your traffic scenario. Of course, these are still simple scenarios what you are seeing here, but the idea is here that showcase that you can already connect this to an existing software, and which means if you have some test of set of test scenarios, you can immediately integrate with this existing software, using, for example, for stress tests and so on. As you can see here, the virtual environment from the top. And in the next slides, I'm going to talk about how to create this virtual environment. So, of course, our mission or our vision is to have a virtual environment as photorealistic as possible to the real life environment. So there are some current state-of-the-art virtual environments. Like in this case, you can see examples from Cesium, which are like pioneering the way how you can create this kind of large cities and so on. Of course, in collaboration with Google and Google Maps and so on. But there is still a challenge for the 3D data. You have kind of crappy environment. So from the top perspective, you can still see very good, let's say, graphics. But if you go to the roadside traffic simulation, or if you use this data, you will have a bad quality of the data. The other way is to maybe use 3D tools like Blender, but also gaming engines to create your virtual environment, and you script the environment. So of course you can create a virtual environment from the real world, but you can also define scenarios that are not necessarily available in a certain location or city. So you can draw, let's say, this virtual environment by yourself. But this is time consuming, because if you want to take care of all the details and so on, it's really time consuming to design new worlds and so on. So our idea is to make this creation and generation of virtual environment as easy as possible. And our idea is to use already available data, especially map data, like from OpenStreetMap. OpenStreetMap gives you a lot of data, not only the map data, but you can also get information about the roads, about the buildings, about even the trees, all the different things, and even the geometry of some buildings. So, and this is basically initial data that we can start with. So our idea is to just take this data from OpenStreetMap and, for example, tell we want to do a simulation, let's say in a city in Berlin or any other city, and you can mark your location on the map and say, okay, you want to create a virtual environment for this location. So what we do is like we take, you have different types of data. You have like roads, you have the buildings and so on. And for each of this type available in OpenStreetMap, we create, then we provide a generator. So it's a kind of modular system that takes all this data from OpenStreetMap, and with the support of the gaming engines like Unity and Unreal Engine, and we create step by step this virtual environment. You can see on the top right here this image. This is just creating perspective of the buildings within the city. You can see the streets and so on. But also, if you go to the street level, you can do and script this by yourself. All the buildings available here are generated with a specific generator, the roads as well, the trees, and all the different street signs and so on. So in this way, you can build all the different generators as a modular system, independent from each other. If, for example, you have an open source 3D tool that generate photorealistic tree, so you can integrate it in the system. It's not like a closed system where you only have a button to create everything. Using closed software is open, that you can, and modular, that you can replace the generator of the building, for example, with something else. So Of course, our goal is to have a photorealistic environment as possible, because you can, as I mentioned in one of the use cases, you can use this virtual environment as also as a source for creating photorealistic data to train AI algorithm, and this data must be as close as possible to the reality. Of course, I mentioned before on this slide, gaming engines like Unreal Engine and Unity. These are usually two of the most popular gaming engines for now. We are now targeting Unity, but this is like the same concept can be applied to other gaming engines and so on. And the advantage of these tools that already provide like physics simulation, light simulation, input handling, rendering, scripting, 3D scene management. So we are not inventing the wheel, because you have a lot of features available in this gaming engine. So our mission is just to create a virtual environment and script our traffic scenarios in these environments. So one important aspect, and I'm highlighting again the two gaming engines, Unity and Unreal Engine. You can see here on the top right and bottom right images here on this slide. These are images created in these gaming engines. I'm not sure if you can distinguish these images from real images. And of course, with the advances in generative AI, we have also another possibility to generate this environment as photorealistic as possible. But imagine you have this data and you use this data to train AI algorithms. So it's like a huge improvement, because you will not necessarily need to create these images from real environment. So one other aspect is because we talked a lot about virtual environments and creating these scenarios and so on. But if we always talk about gaming engines, you will think in the first step on where to render this, and maybe main rendering devices like our PlayStations and Xbox, because these are like improved for gamers, of course, gaming laptops and so on. But we are talking here about a simulation environment. So we are not going to use a PlayStation or this kind of hardware on or consumer devices to run this test. We want to have a kind of headless rendering environment. And this is also what we do. This is a second component which will be provided in the tool set of the Smart Edge, which is dealing with the remote rendering. So basically, we are offloading the computation and graphical processing and rendering from the consumer device, from the local client side, to a remote servers running on cloud servers, for example, on AWS or Google Cloud or Azure. So of course, we have there also access to a vast amount of GPUs. Of course, you need to select the right infrastructure for your scenarios, but you have the flexibility to run everything in a headless mode. And this is why we are doing this as main component, because once we want to run all the different pipelines, testing pipelines on a server, we don't necessarily to need to have a consumer device to run this test. So this is architecture of the remote rendering. Basically, the applications are testing scenarios I mentioned before, which usually are at the end Unity or Unreal applications, covering some certain scenarios and so on. You can still use these tools, the gaming engines, prepare your scenarios and so on. But if you want to go and run it for on a large data set or a large number of scenarios, you will package it as Docker containers, and this will be deployed on remote servers, and you can then script and run it as it fits to your scenario. So this is one important also aspect in a simulation, remote rendering and so on. So this is like was the last slide, or this is last slide with the conclusion about the virtual environment, which allows faster, safer, and more efficient development of traffic scenarios and autonomous driving technology, provides scalability, flexibility, and cost advantages over traditional road testing. And of course, it can be used as a method to improve the software development of this kind of applications.